Hey everybody, welcome back. Today I'm going to hopefully provide a step-by-step guide in building a power supply. And this is my first project where I'm building something from scratch from Schematic. Now, this schematic was given to me by a mate of mine called Paul. And Paul lives in Thailand. He's a guru with electronics, has worked in the field all his adult life. And I must say, if you live in Thailand or around one of the neighbouring countries, or know of someone who does, and you need something fixed, whether it be, valve or solid state, anything, Paul is your man. And I will provide his Facebook address down below, and you can send him a message and he will help you out. He's a really nice fellow. Anyway, let's look at the schematic. And even for me, it's pretty simple. So if you're going to ask me, how does this thing really work? I can't tell you. I don't know. I know we're rectifying AC into DC right here. So that's straightforward. But what we've got, so we've got a transformer, according to the original schematic, 240 volts output. I don't have one of those, so I'm going to put this thing together using parts that I've just got lying around. And I think that's the fun part. So it's a simple tranny. Only need one with HT and 6.3 volts, given the valves that we're using. And the rectifier, it's a 6x4, but you can use a 6x5, a 5y3, whatever. As long as the millivolt rating on the plates is greater than 60 milliamps. So I'm going to use 6x4 on that. Our filaments are A and B, of course. A and B coming off the 6.3 feed. We've got a couple of electrodes right there, and they're bridged by a choke. The electrodes on the schematic are 22 microfarad, but I'm going to use 24. And if you haven't got a choke, like me at the moment, I've run out, we can use a, just down here, I've made some notations. We can use a 250 ohm resistor at a minimum of 5 watts, and I've got some ceramic wire wounds in there that I will be able to either got 250 or I'll cobble a couple together, and I'll try and keep them at 10 watts actually. The next valve is an ECL 82, and I love the way this is set out because we can see each of the pin numbers and what wire goes where, so really simple. Now I don't have an ECL 82, but I did manage to get an ECL 86, and what I've done is I've just compared the pins from both of them. Okay, as you can see, pin 1 to 1 matches, and 2, 2, 4, 5, 6, 7, 8. So essentially, 1 goes to 1, 2 goes to pin 7, 3 becomes pin 8, 4 becomes 4 and 5 stay the same, so does 6, 7 becomes pin 3, 8 becomes pin 2, and 9 stays with 9. And what that looks like, here's my little bit of paper hiding behind here. So if you are using an ECL 86 like I will be, that's the new pinout. Now if any of you guys want a copy of this or on email, I can scan them, and I'm happy to send these to you. Okay, I'm sure there are other valves that we could use. The 82 and 86 are a tetrode pentode valve, so I'm sure there are lots of other types out there that you could use. Again, whatever you got lying around, I reckon. Now, the other question, what is this output? I don't know, honestly, but we're going to find out. I was thinking of asking Paul, but I'm thinking, let's just build it and see, and suck it and see. What else is there? So, I did ask him about the transformer, and I said I'm going to use a radio one, as I said before, and he said as long as we don't exceed 280 volts on the cathode. So if we do, and I'll be testing, the first thing I'm going to be building is the rectifier part with the filter caps and the choke, or the resistor in my case, and I'll be measuring the voltage on the cathode, and if that does exceed 280 volts, then I'm going to be putting some resistors in series there to the plates and lowering the voltage down, and they'll be pretty hefty resistors, I would say, 5 watt minimum. So I'm just going to go and collect some parts and show you what I've got to put it together with. Oh, sorry, the other thing we need. A neon bulb. I had to go out and get some because I didn't have any, but they were dirt cheap, like $1.26 each. So I bought about 4 or 5 of them, and some terminal banana posts for the output. And they're the only 2 things I've had to buy because I've got everything else. So I'll just show you the gear we're going to be working with. So I've got a chassis, and it's a radio chassis, as you can see, but I like the look of it, and it's just sitting around doing nothing. So let's repurpose the thing, as they say, and get rid of the knobs and that. But, you know, I'll just strip it all down, and it's got the right valve sockets that I need. And stripping out all this crap in there too, and I'll be keeping the micas, and I will be keeping these coils as well. Oh yeah, look, I just noticed there's a volume pot with an on-off switch. That'll come in handy for another radio. On this thing I'm just going to put a toggle on-off switch. So I'm going to strip this down and clean it up, and I'll get around to that very shortly. I won't bother showing you that. And I've chosen a transformer, and this one works. Pull it out of an old radio, and I don't know if that says 320 volts or 520, the way it's been pressed in, I don't know. But I did test it anyway. It goes up to about 600 odd volts, but you know, that's unloaded. Of course, it's going to put out a hell of a lot, so it should drop down. And we've got 6.3 volts there too. So, and the rest of the gear, hey, I've got. So I'll get the chassis all cleaned up and ready, and I'll mount this onto it, and then we'll start wiring up the rectifier and the filter caps. Sounds like fun to me. Well, here's the chassis all done. It's cleaned and stripped, and I decided, yeah, I might as well paint the face, so some of that gold hammered finish paint, and I've mounted the power transformer, and that's all solid, and cleaned up the case a bit there, as you can see. And underneath, we're ready for some preliminary wiring. So what I've got, power, my black and red. I like black and red for power. 2 orange, these are high tension, and the black attached to it, that's the centre tap. And the yellow is our 6.3 volts, which will fit around like that. And the orange wires just reach the socket for the 6x4, so that's cool too. And with the power, I'm going to use that existing terminal strip right there, and just solder them up, and then run the power lead wires into there. And of course, I've got a handy little earth there for the green wire. So I'll do that first, get the power hooked up, and then we'll start on the 6.3. And so that'll be our 6x4, sorry, pardon me, down here, 6x4, and that'll be the ECL 3036 there. And you know what, a thought occurred to me, I've got 3 vacant sockets, so I've got plenty of old valves that I don't know what they are, so I actually might wire 6.3 up onto all of them and just whack in some valves. And yeah, trouble is I don't know what the pins are, do I? Since I don't know what the valve, I can work out the pins easy. The heater pins, that shouldn't be hard, because 2 pins will buzz out, and we'll get the thing to light up. Not that anyone's going to see it, but oh well, just use up old stuff that I've got sitting around doing nothing. But anyway, I'll get the power hooked up first, then come back. Okay, so the wiring for the power, that's all done, and as per the schematic, I added an on-off switch, and a fuse, and the fuse, as per the schematic, comes off the neutral wire, or common, and yeah, just feeds into there, into the black wire, into the transformer, and of course our positive, straight into the switch, comes out through the common on the switch itself, to the red, and into the transformer. So, that all looks good, buzzed out correctly, no shorts. And the next thing, I'm going to do the 6.3, and there they are there, and I've changed the colour of one. I've decided to not float it in this case. I read somewhere about valves with indirect heating, completely separate filament, can cause short if you float it. So I'm going to go with the old valve radio setup, and 6.3 center tap. That's going to be earth to the chassis, and the yellow wire I'm just going to daisy chain from one of the pins on the 6x4, pin number 3, and then on the ECL86 pin number 4, and the other two remaining filament terminals, they just get earth to chassis. So I'll get that done, we'll come back and give that a test, and then we'll get on to the high voltage wire. So here's the main feed of the 6.3 volt, so it's coming into the 6x4 on pin number 3, and JC chain it up to where the ECL86 will be on pin number 4, and the earth wire, the other side of the filament, is pin 4 here on the rectifier, and pin 5 there, and again just daisy chain them and just solder them to a nice little earth wire that was sticking out there. So that's all good. I haven't earthed the 6.3 center tap yet. I will be doing that, and I've put in a terminal strip here that'll take the I'll mount the electrodes on there. But for the time being, I'm going to attach the high voltage, and I'll be going on the rectifier pins 1 and 6, and the center tap, of course. Yep, black one. I'll just again earth that probably the same point as the 6.3 center tap. So I'll solder those two orange wires on, and we'll come back and check it out. Right, so I've got the high voltage wires in on pins 1 and 6, and let's run a test. I'll feed some power into it, and we'll see what we're getting. Now, I haven't earthed the center taps, but I'm going to just temporarily earth the 6.3, just so that we can get some readings. And might as well have a look at 6.3 first. Where are my probes? So, black on negative. Get on there. Doesn't want to go. Try there. And over there. Let's have a look at some, pardon me, tipped over the tripod. Let's have a look at some AC voltage, hopefully. And here we go. Yep. Bringing it right up. Look at that. That's full power, and we've got 6.39 volts. Beautiful. Let's have a look at the high voltage. Where are we? I don't need the center tap for that anymore. And onto the plates. Easy to pick. Orange wires. And we'll give it some power. And yep, we got a shitload of power. Voltage going through there. It's great. So far so good. Alright. I'm taking my time with this one, let me tell you. Yeah, I said I'll put that terminal strip in. I'll put another one in there. So I'm going to mount up the 24 microfarads, and I think I can get it in there. That'll go in there anyway. And I'll just, yeah, straight to that earth terminal right there. And that's where the center taps will also go to. And so I will come back and we'll do that together. Well, that's the positioning of my caps, and I've just got enough lead here to get to the cathode, which is really cool. Alright, let's get these into place permanently. Wait for my soldering iron to warm up. Come on, nearly there. Oh, actually, let's give it a bit of a hook. Gotcha! And about there, I reckon. Sorry, you can't see, yeah. Let's get out. Come on. That's done. Good. Yep. And one more thing. Pardon the camera movement. Sort of jammed up in here. Close to the desk. Got the camera on my right hand side. They're done. So I'll get these two cut, and I'll just join them up in there as well. So I'll do that, and then we'll come back and connect up the first filter cap to the cathode, and then after that I know we've got to run that 250 ohm resistor across there in lieu of the choke. I'll just recap what I've done so far, and I've just been marking out. I've done the 6.3s. They're there on the both valves. Center tap is earthed. The high voltage going to the plates. The cathode is going to the first sorry, the first filter cap. Both filter caps are in, and they're both earthed as well, which is down there. So what I'm going to do now is put in the choke, and for that I've got some resistors, and I've lost them. Where did they go? Where did they go? Oh, give me a second. And they're on my lap. So, 2 10 watt resistors, as you can see. One's at 100, one's at 150. And I think you can just see the multimeter. Cool. So I reckon 10 watts is going to be more than enough. Come on. And we've got 250.9 ohms. Spot on. Alright. Now, where am I going to bloody put these things? What I'm going to do, because I was thinking I could put them there like that and bridge both positive terminals, then I'm covering up my rectifier. I don't want to do that. So I'm going to take the easy way out. I'm going to glue them there, and then just run wires. I'll actually glue them right there. At least I can run that wire there, and I'll run another wire up to there. So I'll glue those in, and we'll come back and then we'll give it a test and see what sort of voltages we're getting. I've just prepared it all. The glue's all set. I love gluing stuff in, so at least it's not going to go anywhere. Come on, take. That one's done. And that one's done. Cool. Alright, let's give it some power. I'm curious to see how this thing works, or if it's going to work. So, I'll put the multimeter there. Alright, so let's check the cathode and the voltage. Remember we can't exceed 280 volts. Let's do it the right way. It's polarity. Alright, DC voltage. Let's turn it up. And there's, I've put in a 6x4 as well. Oh, we've got some movement, that's good. Up to 100 volts of mains. That's 140. Wait for it to, here we go. So we're up to, I'm bringing up to 200 volts. So far so good, no smoke, no shorts. $385 volts. Bring it up. Yeah, that's pretty much full power. I know there's no load on it though. That's the thing. Anyway, 400 volts is way too much. So, not having the expertise, I know we need to have some sort of load drawing voltage out of that, and the only thing we've got is going to be that other valve there. So it still seems, voltage still seems excessive, but it's probably worthwhile doing the connecting up the wiring for the valve, and we'll see, especially for the we can connect up the B plus there and put it on the plates. That should draw the power down a bit. And I think, let me see, we'll go to the schematic. Look, I'll connect up the, I'll do this first. Sorry, that goes to pin 3, what's not pin 8. Pin 3 is grid 2 of the pentode. Okay, so yeah, I'm going to connect up and the plates, and then grab a 270k resistor as well, and bridge it across there, and we'll see what happens with the voltage then. Okay, so I've done that job, and as with the schematic, as you can see, off the second filter cap and to pin number 6, and we bridge over to pin number 9 via a 270k resistor. So that's all been done, and there it is. There's a little wire to pin 6. There's nice hefty 3 watt 270k resistor. Alright, let's check. Oh gee, I've got to find those cables again. I've got to organise myself a lot better. So let's go to earth. Let's go to the cathode. I don't know, I've got a feeling that this isn't going to make any difference whatsoever. But might as well have a look and find out. So, where are we? I'll go to 200 volts straight up. Yeah. It's dropped a little bit because there's a bit of extra load on it. 385 volts, way too much. However, it occurs to me that the voltage is just sitting inside the caps, and it's not going anywhere. The circuit's not doing anything. However, what Paul said, do not exceed 280 volts on the cathode. So how about, well, first off, how about we drain these bloody things? That's good. What about you? Great, they're drained. And how about, it's just a guess, I'm going to take the cathode, the wire from the first cap off the cathode, and see if I can reference the cathode itself to the chassis. I'm not sure about this, just a guess, because no matter what I'm doing, the filter caps are just going to store voltage, and putting a resistor in series with the between the cathode and the first cap is only going to restrict the voltage. It's not going to stop the voltage building up inside there. So isolated the cathode. Let's find an earth. That's a good one up there. And let's look at, see if we can get some voltage out of it. Will it read it? Apparently so. Wow. I'm at 200 volts of mains, 265 volts. Okay, so 280 is a magical number. Let's take this up to mains power, full mains power. Okay, 239 volts of mains, 299 volts on the cathode. So I've got to just drop it by, wow, 20 volts, maybe 30, just to be safe. So, I'm going to have to find some resistors and put them in series with the HT lines. So HT line to resistor, drop the voltage on both plates. That should do it. In fact, I recall a 5Y3 on the radios fairly recently. It had the same setup. They were dropping the voltage on the plates for some reason. Okay. I'm not sure what resistor I need, or value resistor, but I'm going to try, I don't know, about 300 ohms, and we'll see if that makes any difference. I'll get myself set up and then we'll run a test. Okay, I've disconnected the HT lines, as you can see, and both of them now are running through these 470 ohm 5 watt resistors and connected back up to the correct pins. Alright, let's see what sort of difference this makes. So power it up, and best you see what the multimeter is doing. And let's go right up, full power. Hmm. 296. And that's not enough. Okay. I can't remember if that was higher or lower than the... No, it's lower, but not by much. Okay, so 450 ohms ain't going to cut it. So I'll need something hefty. I'll find some K. I'll just pick some 15Ks at 10 watts. Now, I know there's a formula for working all this out, and there's probably something on the internet. And if it comes down to it, I'll get onto the internet and see if there is such a program. So, but let's try these 15Ks. I do like to experiment. Just going to bring it up to full power. That'll do, 238 volts. Still 296. Yeah, I don't get it. Okay, had a thought. I'm just going to bite the bullet, and I've swapped over the resistors, and I've just put in 1 megs. Okay, so they're rated at 2 watts each. I think they'll be fine. Let's have a look at our multimeter, and let's give it some power. This has got to work. I mean, Came at full voltage. And there we go, 271 volts. It works. So not exceeding 280. Alright, there's the solution. Good. I will solder those resistors in somehow. I'll come back when I've done that. Well, there's our 1 megs all put in, and just using the terminal spare points on the terminal strip, and working good. So next step is I'm going to run this wire from the cathode of the rectifier down to pin 3. So it's fairly straightforward. So I'm just going to take a wire, hook up wire off the cathode, and just run it up to pin 3. So I'll do that. And here's the finished result. So cathode to pin 3, just like in our schematic. Next one, let's take connection. Well, okay, so it's coming off the second filter cap, which is connected to pin 6, and we're just going to bridge it over to pin 8. Now, what I could do, it's difficult to see, I could run a wire from pin 6 to pin 8. I think I'll just run a wire. Just a lot easier. Run a wire from here straight to pin 8. So yeah, I'll do that, and we'll come back. We'll get through this thing pretty quickly, I think. Well, I've connected up the second filter cap to pin 8 of the 86 valve. Next, I'm going to do pin 7, one of the cathodes. So we'll connect it up to a point 1, which will go to the pot. And I've got a pot, 400k, 500k pot roughly, but it has a nice short shaft on it, so that's good. And I just whacked a 100k resistor across both end terminals, and this now reads at about 102k, so this will work fine. I think I'll put in a terminal strip right here, just to secure things, and that'll make it easy to run other wires, as we can see, up to the positive output terminal, and also help me get to pin 1 as well. So terminal strip there, and I'll connect the 0.01 and connect it up to the pot. We'll do that. I'll come back. Okay, so we've got that 0.1 in, and as you can see, again by the schematic, so pin 7 cathode to the 0.1 to the wiper arm of the pot. And there it is, pin 7 there, and a bit of wire taking me down to the wiper. Alright, so I haven't soldered that on yet because I've got a couple more connections to do, but pardon me, oh dearie me. What I'm going to do next is I'm going to run that line there from the cathode side of the pin 7 and take it up to the output, the positive output post. And if you can see, I've already put them both in, and a couple of little earth lugs there, so I can just whack on any amount of wires that I need to. So okay, where are we there? There we are. We'll just do that. That step's completed. All good. And next, I'm going to do this one. Pin 1 to the pot, the wiper of the pot, 150k resistor. So pin 1, and we'll just attach it to, I'll attach it to there, to the terminal post, and then just run a wire across. So that'll be easy. Alright, that's the next step. Let's do it. Alright, so that one's been done now. So pin 7, and it's running to the output terminal, just like in the diagram there. So Bango, done. Next, I'm going to do pin 1 to the pot, the wiper arm of the pot with the 150k resistor. So looking at it, so there's pin 1. All I have to do is run a 150k resistor from there to there, and hopefully the leads are long enough, and just be able to join it up there, and that'll be all done. Alright, I'll do that. So there's 150k put in from pin number 1. Let's just make sure that's correct. Yeah, always double check my schematic. Pin 1 to the wiper, and of course pin 1 there, and that goes to there, which goes straight to the wiper. Okay, easy. Alright, what are we going to do next? Not much to go. Neon bulb, I think. So connect it to the cathode, the other cathode, whether it's the pentode or the tetrode, I can't remember. One side there to pin number 2, the other side to earth. Alright, well that's pretty easy. Is pin 2, but I like to see the bulb glowing. So I have got, as you can see there, there's that vent up there, or just hole. I'm thinking I'm going to put a terminal strip there, and mount the globe on that. Run a wire from pin 2 to there, and the other leg of the globe, or the bulb. There's my convenient earth point there. Nice. So I'm going to do that. Alright, we'll come back soon. Right, so now I've got the neon bulb in, and as per the schematic, one leg goes to earth and the other leg goes down to, check my schematic, yeah, pin 2. So exactly there. So that's good. And there's no polarity on these neon bulbs, so I checked that up. Anyway, we've got very little to do. Just zoom back a little bit. Oh, there we go. Alright, so all I've got to do now is, for a start, the negative terminal post. I've got to earth that. As you can see, that's earthed. And I've got to connect up a 33k resistor to one end of the pot. The 33k resistor is in, and the terminal is earthed. So that's all good, pardon me. And there it is down on the pot. So all that's left now is one little 39k resistor, and that's going to go right there. So I'll hook that up, and then we can run the test and see if this thing bloody works. Got back soon. Okay, the job's done. Got that last resistor in. Let's see if this thing works. So we'll just monitor the output. And with my negative terminal up here. Let's go to DC. And let's give it some power. I'll take it slowly and we'll just monitor. So 130 volts of mains. Here we go, kicking in. It's working. Right, take it up to 200 volts. Let's see what we get. 22 volts. 28, 29. Okay, full power. So that's 238 volts. Let's see if this pot works. Nothing. Makes no change at all. I've wired up the pot incorrectly. Must have. There's not a lot of voltage either. So let's have a look here. Oh God. My thoughts on this. this is coming out of here. Okay, it's coming off the EL36. I think, yeah, okay, I've just got to swap the that red wire over to the end and put that resistor over there going straight to the terminal. So I'll just swap those over, and I'll just give you a proper look just so you can see. So yeah, put that over there, put that in the middle for output. That sounds looks a lot better to me. Oh well, live and learn. Okay, swap those two around. So let's power it up. Oh, and by the way, I didn't notice if the neon bulb came on. Oh God, if it's only like 38, 40, 30 volts or something, that's not going to power up. So anyway, what do we got? 18 volts. 19. I've got that on off position, so let's crank it up. Yep, that's working, so good. What's it going to go up to? Slow. Oh well, it's only valve, I suppose. 37, 38. Countdown in reverse. See what it peaks at. But it does work. Okay. $39 volts. Just watching it. That's it. That's the peak. 39 point. Oh well, yeah. 1.5. What's it going to do now? 1.6, 7, 8. Stable anyway, reasonably. Took a while though. Alright, let's have a look at the filter caps. So, I'll go with the first one. What's that read? 39.5 volts. The second one reads 39 point, same, 39.2. Alright, now I'm going to ask Paul. He's already built one, he told me, and I'm going to ask him what his outputs. My thought is I probably can increase it by changing these to 1 meg resistors that I put in. So maybe if I go down to half a K, but I'll find out first as to what this is supposed to output. Maybe it is just low voltage. So yeah. Alright, I'm going to get those questions answered, then I'll come back and we'll see if we can make some more modifications. Okay, while I'm waiting on Paul, I had a thought. I just wanted to read what the voltage was on the cathode, and as you can see, 206 volts actually, and it's dropping. And I remember yesterday, before we connected a lot of other things to it, it was around about 268, 267, something like that. So what I'm going to do is I'm going to get rid of these two 1 meg resistors, and like I said, I'll put in 500 Ks, and again I've got to keep within that limit, don't exceed 280 volts. So okay, I'll do that and we'll come back and we'll see if the voltage has changed. Okay, I've changed those 1 meg resistors. I tried the 500K, but it didn't increase the voltage enough on the cathode. So I'm going to 100K, and they're hooked up to the cathode, and let's have a look and see what sort of voltage we get. Alright, so let's power it up. So I'm at about 200 volts already. Let the rectifier kick in. It's looking good. Okay, I'll go up to full power. That's good enough. 237, 239 volts, that's 272 volts at the cathode. 271, 272. Alright, that's what we want. Again, that threshold of 280 is not reached, but we're close. So I'll stick with these 100k, and I'll put them in place, and then we'll see what we're getting out of the terminals. Okay, so I've got those 100k's in place. Not a very neat job, but I'll tidy it up later. Okay, let's check our output. It's got to have increased, surely. Alright, multimeter's on. Power it up. And here we go. I did check the valves, and yeah, they tested okay, so I'm not concerned with them. 70 volts. 75. And let's turn it up. That's as low as we go because I've got the volume pot on 0. Turn up full. Oh, and our little neon globe or bulb lights up. So 106 volts of DC output. That's alright, I'm happy with that. What I'm not happy with is this. You turn it, it's supposed to be, yeah, I want to see it at, well, not 0, but millivolts would be nice. And the lowest it goes is 76. Alright, why? Do I need a bigger pot? One with more resistance in it? Probably. But looking at the circuit, that positive terminal's been fed by the first off the pot, output of the pot, going through that 39k resistor, but it's also been fed from the EL86 valve too. And I mean, it's just going to give me whatever voltage, and it's well, if I can get a good connection, it doesn't really matter where I do it. 76 volts, I mean, So it's always going to give the terminal 76 volts. So it doesn't matter what I do with the pot. So it seems to be a problem with the circuit in some way, shape or form. I'm just going to have a think as to how I might rewire this and see what it does. I'll be back very shortly. Okay, so here we are. And what I've done is, I was only getting, I turned it on earlier, I was getting 80 volts thereabouts out of it. And so, you know, that's exactly what was coming off the filter caps. So I thought, oh, bugger this for a joke. I got rid of those 200k's and I put in 47k's, or thereabouts, yeah, 47k resistors, and now I'm getting around about 260 odd volts. So that's all good. I mean, when I was testing the cathode output, and the cathode was not under load, I got good voltages, you know, what was it, 270 odd volts, I think. But clearly, in my mind, it's got to be under load, so, you know, the whole circuit's got to be connected up and working. And, well, let's just turn it on and show you. Just connect up the multimeter. DC voltage, and let's power it up. Here we go. 271. Okay. That's good. It's still under 280. So we don't want to stress out that, I think, the ECL 36. So 272 volts, that's at maximum output. If I turn the pot down, it only brings it down to, as you can see, 238. So, you know, if you're always dealing between those two ranges, and that's all you need in voltage, this is perfect. But I still want this to be, you know, to come down to, well, you know, 1 volt at least, or just a bit under. That'd be nice. So, turn it off. I've got a thought. Run this by you. This is what I'm going to try. Just bring the schematic up again. And so we've got pin 7, the cathode, one of the cathodes anyway, and it's as we know, it's running straight up there. So there's 200 and something volts just always going to be present on the output terminal, on the positive. Some of it goes through that 0.1 capacitor into the pot, and I reckon that'd probably be minimal. So my guess is, what I'm going to try, I'm going to remove the wire from the terminal. I'm going to put it straight into the input of the pot and see what happens. And you know what? Just do it now. Just jumper it in. Probably couldn't see that, but I've just unsoldered the wire from the terminal post. Let's just grab a jumper, keep it away from any metal bits. Let's attach it to the pot. Alright, multimeter back on. And full power. I'll turn the pot up to maximum. Well, everything's working, neon bulbs glowing, and okay, so I've got 241 volts, and I suspect that's what I would have on the filter caps. Oh, well, that one's 244, that's alright. Back onto the terminal. Cool, now let's see how far down we can go. 67, well, that's a big improvement. And everything looks stable at this point anyway. So the voltages are all within the region that we want. And I'm happy, you know, with 240 odd volts, that's fine. So I want to bring that down, 67 volts down to, well, as low as I can possibly get it. My first thought is, I'm going to change the pot. And it's a 100k pot, so I'm going to put a 1 meg pot in there. And we'll see what that does. So I'll go source one of them, and we'll try it out. Okay, I've got that pot. Jump it in. Looks a bit of a mess, but it all corresponds. It should be working. I don't think anything is touching that shouldn't. Alright, so I'll turn the pot up to maximum to start with, and again we'll just monitor that the output voltage. You can see that. Alright, let's power it up. And so far so good. It's taken it up to 288 volts, so sort of stressing out that little bit over. Okay, so that means I might have to, if this works, let's find out if it works. Let's drop the voltage Right down, how far down can we get? 9.5 volts. Cool. That is cool. So, what I might do, what I'm thinking now, is there is, I'll show you, see that little resistor there, the blue one? Well, that's only 39k. If I can, my thought is if I increase that, and I've only got to drop it down by, say, 5-6 volts, and that might work, I don't know, but I'm going to give it a go. And yeah, I'll come back when that's when I've jumped it in another one. Well, I've jumped it in a 1 meg pot, and I've actually gone overboard, and I put a 10 meg resistor between the pot and the output terminal. So let's see what we get. So it is at the minimum, it's 3.2 volts. Let's turn it up. And it's 89 volts. Okay, so now what is my filter cap running at? 289, so I'm 9 volts over. And here's where I would chase my tail. If I were to change those two resistors and increase the voltage, and increase the resistance, I'm reducing the voltage, which again is going to give me these problems of what I'm outputting and the maximum minimum. And it's more the minimum that I'm concerned about. But I'll tell you what, 90 volts is pretty much what I want. Well, actually, look, I might try a 500k resistor and pot and see what happens. So I'll just go grab one of those. 500k pot is in there. Let's power it up. $273, 280 volts. My pot's not working. What have I done wrong? Oh, here we go. Yeah, only drops down to 166. So, well, duh. I had the 1 meg pot in there. It was pretty much the same, I think. Oh, no, I don't know. No, I didn't. No. Sorry, 100k to 500k. Yeah, that's just not enough. And that's, sorry, pardon me, that is at the filter cap. My apologies, didn't move my terminal. So we're down to 5 volts. The maximum. Is 86. Sorry, clips are coming off. 88. Right, I'll have a think about this and I'll weigh it up in my head, and I'll come back with a final decision. I made my decision. I've decided to go with the 2 meg pot, and I'm going to compromise on the increased voltage at the cathode, so it's only over by 9 volts. Not sure how much it'll stress the valve out, a little bit I guess, but the voltages I'm getting at minimum 1.5, that magic number for a filament, for a battery set anyway, and 90 volts for the plate of a battery set, and that's really what I want. I mean, I've got that other great big honkin' power supply there that goes from 0 up to 1200 volts, and I've got my little FIT, which goes up to what, 40 volts? Yeah, so this is I think a good compromise there. So anyway, that's what I'm going to do, and I'll make the adjustments on my, I'll drop another schematic with this particular layout, and I'm going to get this all back together again, and we'll finish up the video with the demonstration.
Look, has that got style?
Style, it's faultless.
Rather fashionable.
Faultless.
And that collar, hey, smarter than the average.
Absolutely faultless.
It's a man's shirt, really.
Oh. What?
Yeah, faultless. Got several myself. Best shirts I've ever had. You know, one thing bothers me.
Huh? What's that?
Why does everyone keep looking at us, too?
Well, we do look a little odd walking backwards.
Hey guys, well, I'm back. Nice shirt, huh? Yeah, real 60s ad. See all the people. Oh, I'd love it. Start looking at her. These days, nobody turn their head, I don't think. But anyway, here it is. Unit's finished, as you can see. Not sure about keeping that particular knob, but it'll do for now. And of course, it's going to look a hell of a lot better when I get a panel meter there. And now I know the voltage ranges, so I might actually put 2 on there, I think. But you can see I've got the power switch, been there forever, and I've added another switch to switch between voltage ranges. And I'll just show you. That was one modification. Oh, apart from the lights, of course, just wired into the 6.3, and I've had those bezel lights sitting in my tray for a couple of years. Might as well put them to use. You can see that these 2 resistors here, I've added those in. One of them, that one comes directly off the cathode and goes to pin number 2, which on the EL86 is the cathode on the tetrode, and the other one comes from the second filter cap down there, which you can just see, and that's going to pin number 7, which is the cathode on the pentode, as well as grid 3. And the voltages were over 280, and again I'm just going to stick with that number because that's what I was told. And so whatever the values are, I can't remember, but just a bit of trial and error until I got it just down under 280, and they're around about, it's feeding at 277 volts at the moment. And here's the switch, and let me move this around a little bit more so you can see. And it's a mess of wires, of course. But originally the output of the pot down there was going through this 22 meg resistor, and that's what gave me a minimum of 1.5 volts and a maximum of up to close to 89 or 90 volts. And I thought, well, hold on, what's the voltage coming straight off the pot? And something like 5 volts, and goes all the way up to about 270 volts. And I thought, well, that's 2 voltage ranges, so I've just put a switch, little simple single throw double pot, single pole double throw switch, and yeah, one end just goes through the bloody resistor, the other end just bypasses it completely and feeds the output terminal post. So cool. But let's turn it on, and we'll just check those voltages. And let me earth it. That'll do. I'll get my multimeter into view. There we go. Go to DC. Oh, pardon me. And let's turn it on. And the lights have come on, which is cool. So we'll just look at the cathode first. Wait for it to warm up. So 285 volts. There we go. Okay. And pin number 2, I've got 271. It's okay. And pin number 7, 274. Probe keeps slipping off. Close enough. And on the output terminal at the moment, 84 volts. That must be at maximum. Yep. And 1.5 at minimum. Flick the switch over and it jumps up to 4 volts, and at the upper end of the scale, 271 volts. So that's cool. Two dual voltage ranges. I'm more interested in the lower end, the 1.5 up to close to enough for 90 volts. And for me, I'm thinking battery radios, you know. And that's what I'm mostly interested in. But anyway, I've enjoyed doing this. It's been a real eye-opener, and I've learned a fair bit. And I will make the original schematic available that I've received, and I'll also update my schematic on what I've done in case you want to build it this way. But of course, it also even come down to the power output of the power transformer. And in the original, it said 240 volt output. Well, this one's about 350 because I can just use a radio transformer. And you might want to have one that's going to output a little bit less or more. And you just have to make the necessary adjustments with the values of the resistors. But I think the caps, they just stay the same. And let's face it, there's not much in this at all, is there? No. But anyway, again, thank you for watching, and I will catch you all again very, very soon. So please have fun and take care. Bye.